The next topic in unit 4 is memory allocation. Okay, so memory allocation is done in two ways: one, contiguous memory allocation; two, non-contiguous memory allocation. What is the meaning of contiguous memory allocation? That means if a process px, okay, this has to be loaded into the main memory, the entire process px has to be loaded at one place. Entire process px is loaded at one place. That means if px is resided in this particular portion, that means all the contents of ps has to be loaded here. You cannot store half of px here and half of px here. Okay, so this concept is called contiguous memory allocation. Then second one is non-contiguous memory allocation. That means a process has to be stored into the main memory. That means px has to be stored into the main memory. So some part of the px is stored in this particular memory segment, and other part of the same process will be stored in this particular segment. And if required, there is some more part required, you can add this particular segment also. Okay, contiguous memory means entire process has to be placed in one particular segment. Is called contiguous memory allocation. Okay, non-contiguous means the process can be split and stored into different segments in of memory, main memory. Okay, so let's see what is contiguous memory allocation. In contiguous memory allocation, there are two ways we can allocate the memory to process. Okay, so first one, fixed partitioning scheme; second one, variable partitioning scheme. Okay, in fixed partitioning scheme, the main memory is divided into different sizes of fixed blocks. Okay, suppose this block is of 20 MB, and this block is of 30 MB, and this block is of 30 MB, and this is of 10 MB, this is of 40 MB. Okay, this is of 20 MB, and this is of 10 MB again, and this is of 30 MB. Okay, so total size of this one is 50, 80, 90, 130, 150, 160, 180. So total will be 180 MB. Okay, out of this 0 to 180 MB, okay, it will be divided into different sizes. It will be divided into different sizes. That means, and these sizes are fixed. Okay, these sizes are fixed. So there is a condition that one partition you can store only one process. One partition you can store only one process. So the degree of multi-programming, that is the number of processes that is resided in the main memory, is equals to your number of partitions, is equals to number of partitions. Okay, so that means whenever a partition is free, you select one partition corresponding to their size. You can store that particular partition. That means let us take a process px with 15 MB. Okay, a process px with 15 MB. So you can find an appropriate partition. So you can 15 MB, you cannot store it here, you cannot store it here. Two 10 MB whole partitions are there, you cannot store it. The best way to store is either this one 30 MB or 20 MB or 40 MB. Okay, so that more than 10 MB, the requirement is more than 10 MB. So if I store this in here, okay, because when it comes to first come first serve, if I store this particular thing here 15 MB, what is the process px? I am storing px. So it is storing in the first partition. Px is stored in the first partition and takes 15 MB of total of 30 MB, and makes remaining 15 MB unusable. You cannot allocate this remaining 15 MB to any other process, because one partition is given completely given to one particular process. Okay, so similarly, if a process with a size of 21 MB, okay, with a size of 21 MB, you can take this, you can find either 30 MB process or 40 MB process. You cannot store it in 10 MB or 20 MB. So what you have to do, you can take this particular 30 MB and you can store it here. Okay, so this makes one more 9 MB. Okay, this makes 15 MB unusable, and this will take py 21 MB data. Okay, so similarly this particular thing has been allocated with 16 MB. Assume that pz is allocated with 16 MB and makes 4 MB unusable. Okay, so this side 4 MB unusable, and this 10 MB, and let us take this one. Assume that 22 MB. Okay, that gives how much? 18 MB unused. Okay, then this one, let us take 15 MB, so 5 MB is unusable. Okay, there is a lot of unusable memory segments will be there. So let us take this one, a 10 MB, which is already completely unused. So a, so this is pb, let us take this is pc, and there some particular 28 MB, because something 28 MB, you can take this one as 2 MB. Now look at here, what is the each partition? In the worst case, each partition may have some memory segment that is left. Assume that this partition consisting of pd, that is 10 MB. Okay, so it is full, it is full. Now let us take all the free partitions, let us count all the free partitions. So it will be 15 plus 4 19, 19 plus 9 28, 28 plus 2 30, 30 plus 18 48, plus 5 53. So total of 53 MB free is there. Okay, but let us take each partition is already have some particular memory that is wasted, and you cannot allocate it to new process. Suppose that there is a 11 MB process that is came to system newly. Okay, 11 MB process, assume that this is pk process, pk. If you look at here, there is 15 MB free here, and followed by 18 MB free here. In this particular partition, pk will be allocated, or in this particular partition pk will be allocated, but process pk will be allocated. But there is a rule that only one partition given to one particular process. That means until and unless the memory segment size, that is more than 11 MB, more than 11 MB is free, then only pk will be allocated. But look at here, even though there is a 53 MB free memory is available, and we can allocate still, if it is same rule, still we can allocate either partition 1 that is having 15 MB, or partition that is having 18 MB left. Okay, but we cannot allocate this particular pk to any one of these particular partitions. Okay, because there is a fragment of memory that is wasted, still we cannot allocate pk to these particular partitions. Okay, so this wasted memory or fragmented memory, wastage of this particular fragmented memory, it is called internal fragmented memory. Okay, that is called, the concept is called internal fragmentation. Okay, what is internal fragmentation? It is a fragment of memory. Okay, it is a fragment of memory that is internal to the partition which is wasted. Okay, it is wasted, the fragment of memory which is wasted, and we cannot use that particular memory. Okay, so this particular fixed size partitioning is used in early days, we are not actually using today. Okay, so this fixed size partitioning leads to a problem of internal partition. Okay, internal partition, where the memory is divided into different fixed size partitions, and we cannot use the memory, we cannot use the memory which is wasted. Okay, right.